I'm Tobias Revel.
And I'm Radha Mystery.
And this is Futur-ish, a podcast about how nothing is new and everything has happened before.
We've been working and playing in futures for over a decade of hype and bluster amidst increasing uncertainty and complexity.
In each episode, we explore a recent event or signal for its historical context and speculate on future possibilities.
And make it make sense for people like you and me.
I always find the idea of taking holiday during work time a bit ludicrous because you take a week out, all that means is you have to catch up with an extra week in less time when you come back.
But then, when would you take a holiday then?
Well, this is why I miss academia, because I used to work when everyone else was on holiday and take holiday when everyone else was at work. Because the great thing about the summer in academia is everyone else goes on holiday and I can just go on with stuff. There's no one nagging me.
But now that you're in a full-time corporate gig,
which never ends, there's no break.
This is just the way of life. We're going on family holiday in a few weeks, actually. Otherwise, we will not be going on holiday. Jamaica.
Oh, nice. Wow.
Yeah. Yeah, for a week, which in US times is like the whole month of August, basically.
I've got no notion of Jamaica. Apart from colonial history, I've got no sense of it.
Well, it's an island nation.
I got
if
that.
You didn't know that. I know we haven't recorded in a while, but there's a thing I want to talk to you about.
Every time you say it sounds like a threat. I can't help but be like,
okay, when I was a teenager,
the instinct I have that kicks in and goes, oh, I'm in trouble.
No, okay, I was going to just say this because when I was in college, I went to architecture school in New Orleans, and I used to, and in my fourth and fifth year, I lived with my aunt and uncle, and I was really close with them, and they were kind of like a second set of parents. But it was funny because every time I was in trouble, my aunt would always pull me aside and she'd be like, I've been noticing this thing. And I knew I was in trouble when she said, I've been noticing blah, 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 blah. So I was accused. So I was like, I get the trauma response. I'm a little hesitant to, well, part of this is probably going to, I don't know. Will it embarrass you? Are you embarrassed of your past work? Because I feel like you shouldn't be.
No, I'm not. I'm looking for a glasses cleaner, by the way.
Okay.
But it's probably okay. No, I'm not embarrassed of my past work. I'll rephrase. I'm not embarrassed of any of the past work that anybody knows about. The work that's widely publicized in the public domain. No.
Okay, so anyway, so I was I had a day yesterday. I had a really great series of conversations, and I kind of had a moment where I could just go down a rabbit hole, and I found this academic paper, and first let me just read you the title of this academic paper, and then you can tell me what you think it's about. Okay? And then I will share the embarrassing part, which you said is not embarrassing. So the paper is titled Sensory Motor Control of Robots Mediated by Electrophysiological Measurements of Fungal Mycelium.
Is this AI generated, or is this just some grad student desperate for attention?
This is not AI generated. Who's that author who was oh God, who's notoriously dense to really not dense dumb, dense
Heidegger?
No.
Foucault's not that bad.
More contemporary.
I mean, there's a lot of people who are too dense to read.
Goodness gracious. I'm very annoyed with myself right now because I cannot find this, and we're digressing, but I have to figure it out. Yeah. Gravity's Rain. Is it Gravity's Rainbow? No. Yeah, but I don't think it's him because he seems too old for what I'm thinking of. It's one that's like Gravity's Rainbow. There's a picture of him with a bandana on.
David Foster Wallace?
Yes. Thank you. That's who I was thinking of. Dear Lord. Why did I start talking about this again? This is going well.
Because you said the title of that paper and it had robots, mycelium, electrolytes, something like that.
Yes. So did you look at any of the links that I shared the other day?
As usual, I have been too scared to look at the prep.
So the paper was put together by researchers at Cornell University. And basically what they have figured out how to do is to use the energy generated by fungal mycelia to power robots that can respond to uncertain conditions in the environment, meaning that it's not this controlled environment. They're trying to build these robots to be able to handle the chaos and uncertainty of our natural existing environment. And one of the first applications that they're thinking about are agriculture and food. basically. The lead author is this guy named Anand Mishra. He's a research associate in the organic robotics lab at Cornell. And the did you look at the robot? Because it looks very cute.
All right. Okay. Yeah. Okay. Okay.
It's a cute little robot,
Yeah, it is
right?
cute.
So it's got, yeah. So like if, for folks who are listening in, it's this little like spider like robot almost. It has 5 legs. It's kind of like, what would you call that movement? Kind of like jumping around a little bit.
Yeah, it's like basically a sort of accelerated starfish.
Yes, that's exactly right. That's a great way of putting it. So basically, what they're trying to do is to build these kind of biohybrid robots to be pretty autonomous, right? So it's like it can kind of sense what's happening in the environment. It doesn't need to have inputs provided or kind of cues provided by another system. One of the kind of future uses that they foresee in this are within the agricultural and food industry to do things like sense soil chemistry and row crops and then decide when to add more fertilizer. So as part of this research and in the paper, they outline that the robots completed 3 experiments and they had 2 different robots. One was this soft robot kind of shaped like a spider, and the other one was this hard wheeled bot. So in the first experiment, the robots walked and rolled as a response to the spikes in the mycelia's signal, but it's basically kind of like these neural signaling mechanisms that are being provided by the mycelia. And then the research in the second experiment, the researchers stimulated the robots with the UV light, which actually caused them to change their gait. And then I don't know why I just did this, but that's what I imagine, like a runner's gait.
Makes sense.
Like frolicking, like an antelope or something. And, but what they were trying to prove there is like, can we demonstrate the mycelia's ability to react to their environment? And then in the third scenario, they were able to override the mycelia's native signal entirely. And so like I said, again, I think what's interesting here, it's a small, tiny little robot that's able to kind of operate in a chaotic environment, right? Which is the same way that like a human being walking down the street would have to think like, oh, there's a person behind, in front of me, or there's a car crossing, or the light is too bright here, let me turn around, or like there's a loud noise, things like that. That's quite a far leap, but in my mind, that's kind of what at a micro scale, I would imagine is being tested out here in some manner. So one thing I wanted to say though, is while I was researching this and looking at it, I was like, this reminds me a little bit, just like the mushroom energy piece of a project you had done ages ago when we were baby foresight
Yeah, I
researchers.
wasn't even a baby foresight researcher. That's still a master's student.
Okay, so if I bring up the Design Boom article that was written on your project, it's from July 18th, 2012. God, Design Boom is 26 years old, Tobias. That makes me feel old. But anyway, so 2012, I think we were working together at Arup as like contract researchers.
Yeah.
But you did this project called New Mumbai. Can you share a little bit about this?
I can, yeah, because it does still come up all the time because it's one of those things that has some staying power. Largely, I think, for aesthetic reasons, which is perhaps something to talk about mushrooms and aesthetics. So we were set a brief. I'll go from the beginning. We were set a brief that was about working with an emerging science. And so we were told to go out, dig up some interesting research or science and develop a speculation or a fiction that talks about the potential implications of that science in the future. And I found a group of researchers who had basically figured out that you could accelerate the amount of collagen being produced in the cells in vegetables and plant matter, and that could make them larger. So genetic engineering to make larger foodstuffs. They were focusing on agricultural products. But what my interest was what happens to technology when it's usurped, and this idea of the subversive user. So the user who takes something and subverts it beyond its original use case. What if someone managed to get hold of this technology and didn't use it for growing bigger food, but for providing critical infrastructure like energy? And so in New Mumbai, it's the fictional story of the Dhahavi slum. Apologies if I'm not pronouncing that correctly, in Mumbai, which is one of the largest slums in the world, who have managed to get hold of this biotechnology and have used it to grow these large fungi, these large mushrooms, that are all over the buildings in the slum, and they use those like potato clocks. So basically, I don't know if the robot works the same way, but the acid differential between a cathode and anode provides enough energy, and they use that and these incredibly large mushrooms that are all over the buildings as sources of power. And so originally, it was a series of images and a kind of series of diagrams to explain that process, and then I ended up later on doing a 9 minute, I think 9-10 minutes, something like that, fictional documentary. So it's a documentary as if this was a real thing, and it got sort of 4 or 5 actors to play different parts. There was like a local cop from Mumbai. There was the European bioscientist who'd come up with the technology. There was a kid who was there working in the slums looking after the mushrooms, and they all told their story, and it was all interspersed with some what by modern standards would be considered some pretty cheap renders and stock footage. Up until 3 or 4 years ago, I was still getting people saying, "Hey, what happened to these mushrooms? They should have taken over the world. We would have thought by now that everyone would have this." And I have to go, "No, it's a fiction. It's not real. It's a speculation, and it's not really about mushrooms either. It's about the sort of innovation cycle and technology and who gets access to what and so on and so forth." And I think there's probably, reflecting on it, there's quite a few sort of clever rhetorical tricks in there that made it quite impactful. So associating the idea of like urban slums with mushrooms, which are also associated with like rot and uncleanliness and things like that, but actually turning those around and making them a source of power and independence and resilience was quite a sort of powerful imagery, I think, that people sort of latched onto. And it also it did a very good job, I think, of something that's very hard to pin down when you're trying to do it quite intentionally, which is like taking stuff that's deeply familiar but making it slightly unfamiliar. So all of the elements in that project are all familiar: mushrooms, growing vegetables super large, and impromptu decentralized power sources in disconnected parts of the grid. It's a long way of putting it, but you know what I mean. But it was bringing those things together in a way where it was like, oh, that combination of things is quite interesting, and I think that's why it's had a certain staying power as a project, and people come back to it. And actually, I keep all my I don't know if you do this, so everything I've been published in or I've written is up here on this middle shelf, and there's actually probably more articles about New Mumbai than anything else, to be honest with you.
Like on display or just like on a stack?
No, even my wife didn't know that's what that shelf was. when we were moving, and she was like, "How do you order these books?" And I was like, "Well, there's like all the sort of philosophies at the top there because I'm never going to read it." Then there's like tech, and then there's design, and then these are all my publications. She goes, "Oh, really?" Like, yeah.
My stuff is just like hidden in one of,
including like my own book.
Wait, you have a book?
Yeah, I have a book.
Tobias?
I mean, it's co-authored.
What is it called? Yeah, but what is it? How did I not know this? Oh no, I did know that.
See, that's everyone's reaction to my book.
Sorry.
Oh yeah, I know about that. Yeah, I didn't read it, didn't buy it.
I did know about that. But that was like, wasn't that a few years back though?
Oh yeah. It was. It was written pre-COVID, and then it was published, I think, like 2020 or something.
That sounds about right.
When was it published? 2021. So it's published in 2021, but we wrote it in like 2018. So for a book about digital design, it goes out of date pretty quickly.
Yeah.
Anyway, but that's New Mumbai. But I do have. I mean, so this is. So there's a couple of things here. One is, from your description and from glancing at this article, I'm not sure I follow what's, other than being quite a novel experiment, which I totally get. I'm not sure I get a lot of the qualifying terms, like to quote, the resulting biohybrid robot. I like that. The resulting biohybrid robot can sense and respond to the environment better than a fully synthetic counterpart. And I'm like, well, does better mean faster? Does it mean more powerfully? Like, what is that? Robots are pretty good.
So here's what I got from kind of digging into this a little bit more to understand what they meant, which is that when you have purely synthetic robots, it's their movements, their responses are based on programming that has been predetermined and coded, right? So it's saying if A happens, then do B, right? Or if C happens, do E. And so what this is saying, from what I understand, is that if A isn't anticipated, can the robot still react?
Nice. Okay.
In figure B, like in factor B.
Yeah.
So it's almost like developing these like neural linkages where the robot can respond to unanticipated factors, external factors and inputs that have not been pre-programmed or
Right.
predetermined.
Got you.
So you could imagine kind of like setting a swarm of these things loose in an environment like a farm where you don't always have control over everything, right? Because it's like I was listening to this podcast with this woman who sits on the National Agriculture Board, and she's a soybean farmer. And she was saying that there are so many different factors you have to consider when farming, and there's so many things you don't have control over. You don't have necessarily have control over the amount of like sunlight. You don't have control over pesticides. You don't have control over, whether there's going to be a new disease that leaps up, or like how much global warming is going to change in the next year, or how the wind patterns are going to affect your crop, or, like all these other things. You can try as much as you can, but once you've taken kind of robots out of a factory or out of a controlled environment and placed them in contexts like, primarily natural kind of environments, you add a lot more chaos to that context, right? And so it's this ability to kind of like create a neural network that has a similar level of cognition to something that you might call a brain.
This is a mushroom. It
Okay.
doesn't have a brain.
No, it doesn't. It doesn't. But you can still develop an input output kind of feedback loop, right? And so that's kind of what I've learned is the potential of something like this. Now, this is like very, very early days. The paper was just published in August of last year, 2024. So it's been, as of this recording, it's been like 8 months, right? And it's part of a lab where they're trying to figure out how to use mycelia, or kind of these like this model of like biohybrid robots in at various scales and various applications, various kind of use cases. So what they really want to kind of think about is like how, like they said, that this paper is the first of many that will use the fungal kingdom to provide environmental sensing and command signals to robots to improve their levels of autonomy. Like that's kind of like the baseline of the paper abstract. And what they've done is grow mycelium into the electronics of a robot. And one of the things that was really interesting to me as part of this was Anand Mishra kind of listed all of the collaborators that they had as part of this. And I don't think it's new to say that there are all these like transdisciplinary teams now, right? Like that the slashy kind of designer, scientist, engineer, like Willy Wonka practitioner is not a new concept.
Willy
But
Wonka is not a robust scholar.
I don't know. For me, he is. He invented so many different kinds of
I think he's.
chocolates
I
and
think. I
candies
think he's an acquisitions expert. I don't think he really invents anything.
You've been sitting in corporate for too long, Tobias. So he was talking about kind of like the team that they had to use and the interdisciplinary researchers that they collaborated with. So he said you have to have a background in mechanical engineering, electronics, is it mycology, neurobiology, some kind of signal processing. They worked with a professor of plant pathology and plant microbiology to learn how to grow clean mycelia cultures.
Can I just check something? Because this is an important
Yeah.
detail. Is this operating off mycelia or off mushrooms?
Mycelia.
Okay, that makes the difference. Yeah.
So like the vegetative part
Yeah.
of the
Not
mushroom,
the
right?
sex organ, because it would just be a dick pot.
I'd be interested in seeing what that would be like.
Those exist, Ryder. Those exist already.
But I think, but like, so this is what I'm saying is like, and I will say this, I remember, when I teach and stuff like that, like everyone is interested in mycelia. Like it's had its own kind of hype cycle, but I feel like there's something here. I have this interest in how we begin to expand our definition of technology, right? Beyond the kind of shiny, sexy, like Silicon Valley familiar futures we get fed, and these devices that are like chip embedded and programmed by computers and things like that, right? AI, all of that stuff is like the shiny, sexy stuff. But there's so much of the synthetic world that we have built that's based off of natural, organic plant systems. And so when we start to think about something such as like the network of connected things, right? As part of this like IoT Internet of Things, um, I'm so curious about how we might begin to expand that language and the definition around technology and like the connected network of things. Typically, if I were to come to you and say, "Hey, I saw this paper about a robot," like there's already kind of a value embedded in that language, right? and an image we have of what a robot looks like. But if we start to have these robots that are like more based in natural systems, I think that begins to expand our sense of like what technology is, what networked systems could be, right? And what our connection to the natural environment around us is, and what we can learn from the natural environment. And that's my thesis for now.
So we don't have time to talk about this, but we actually should. I'm going to park the fact that I really find the over-aestheticization of natural phenomena concerning. But I would also suggest that part of the reason why an organization like Dazine is kind of jazzed by this is like, oh yeah, talking about mycelium is cool.
Of course. Yeah. No,
Yeah.
and everyone thinks it's cool. And it, like I said, it's every grad student in design school is trying to do something with mycelia, at least for the last 5 years.
What it speaks to me is a very real kind of mega trend, which is probably that we're running out of computation. And I mean, we're running out of computation in physical extractive terms, in terms of how well we can engineer computers, but also actually the fundamental logics of how we built computational infrastructure was based on a set of assumptions that may be wrong. And people don't like talking about that because it's a very scary thing to acknowledge that maybe we've got this wrong. We could talk about this for hours. You know, everything from speculative computational components that should exist but can't be created, like memsisters. People have actually done lots of experiments with natural materials to try and make memsisters, including, I think, mycelium or algae. And there's obviously lots of other examples of bio-computation. So slime mold computers are very popular, for example. But the one it made me think of that's more recent, have you come across the Cortical Labs CL1?
I don't think so.
So this is a genuine, swear to God, biocomputer, like a computer that runs on biological material. Like in a stack, you know. So it's not
cool.
It's not. Now I can't speak to how well this works, but our colleague Mona introduced me to this a few weeks ago, and immediately I was thinking about questions like, well, how much computational power does it have? Like, what's its speed? And I was reading through the stuff, and it's not there. And I was thinking, well, but that's because it's biological, like it's non-standard. It can't be mass-produced in the same way. It's going to have variances to other machines. And similar to what you were saying about the mycelium robot, it's going to have emergent properties as a result of that condition, which are going to be unpredictable and novel. And so immediately, I haven't had time to think about this, but then what's the application of this? You know, how might it be used? How might it reshape what we think about as computation, what we use computers for? Etc. etc. It has a lifespan of, I think, 6 months or something.
Can I ask you something?
Yeah.
Because you brought up an interesting point. How much of a project like this might also be motivated by the fact that we are like running out of silicon and access to the things you need to develop a system for computation?
My instinct would be to say it's less about resource and material, because frankly, recycling silicon would still be cheaper and easier to do than building a computer out of synthetic brain matter. Like, it's still an easier thing to do. My instinct is actually more to what I was getting at and hinting at, which is that within computer science, there's a growing sense that the rudiments of computation, which we basically haven't changed since the 60s or 70s, it's just stacking chips on top of each other and running binary code through them as fast as you can. That might not be the end state of computation, and there might be a bit of a reverse, a U-turn, and going up a different branch of what we could have done possible. So biocomputing is absolutely one of them. One of the great sort of pieces about this was a scholar called Sarah Hooker, who worked at Google at the time, and she wrote a paper in 2014 called The Hardware Lottery, which essentially says the reason we've got the AI we have is just a coincidence. Machine learning and neural networks became the successful version of AI just by coincidence of the hardware. There's also physics problems. So you have a problem where once you've got transistors so close to each other on a chip, because you're going so small, you're using what's it called, photographic, the lithography that they do over in Eindhoven to make this work. The magnetic flip of one electron in one transistor influences the transistor next to it. That's how small we're talking, right? We're talking like fundamental physics at that scale. And so they're like, well, how you can't really go any smaller, right? We're running out of things. And so whether it's permacomputing, whether it's biocomputing, there is a concern, I think, that's underneath, that we're assuming this keeps going forever and ever and ever, and we'll just solve all the problems we come across. And A, we're not really solving those problems, and B, we're running out of road to keep going forever and ever and ever. So I contextualize that cute little mushroom bot in that of being like, what else is out there that we can try and do the things we need to do with? What other materials and other processes can we use to achieve the same effect? because this road might be running out.
Well, that just still feels extractivist, though.
Oh, yeah. Because, I mean, my counter to let's build biobots so they can respond to the natural environment is we've already got lots of things that respond
Yeah,
to the natural environment. We don't need
that's
to create
true.
robots to do it.
There's another part of it, which is like this idea that it's still something that is co-opting natural systems in a way that feels towards kind of, I don't know, a capitalist outcome, but like that still feels kind of like human beings taking from the planet
Yeah.
in some way. And that version of the future doesn't sit with me as well. But I'm wondering like what the happy medium is. Like if
Yeah.
this got into the right hands, what could it be?
There are some use cases where I think would be entirely appropriate, like disaster relief, for instance, where there's,
Mm-hmm.
that you need something that has the motive power of a human being that can respond to emergent environments
Yeah.
like a living thing, but it isn't putting someone else at danger.
And it's also like not reliant on a working energy grid
Yes.
potentially.
Yeah, exactly.
You know
So
what I'm
for
saying?
that kind
Yeah.
of environment, great. I think I can totally imagine that application. But also, this could also be another part of the push for slow computation and slow AI, another type of computation, which isn't about getting the result you want to do in maths, but perhaps doing something else entirely. A thought experiment I put forward is that in 2001, there were two great science fiction films released. And I mean great, they're very good. Minority Report, Steven Spielberg, with the brilliant production design of Alex McDowell, and David Cronenberg's Existence, both of which present technological visions of the future. Now, Minority Report will be deeply familiar if you would recognize its features immediately. Its gestural interfaces, its augmented reality, its eyeball tracking, its artificial intelligence, its predictive analytics, blah, blah, blah. Existence is biocomputing, game pods, climbing inside someone else's head via a biological interface. But in 2001, both of those things were science fiction. So why has one resonated for the last 24, 25 years, while the other is sort of, is still a bit of a cult classic, but it hasn't had the resonance with the world of futures and technology and design that Minority Report did? And that's, again, a bigger discussion. I've also written whole essays about that very question. But it's because there's a certain imaginary of what computation is, what it should do, what it should do for us. And that relies on a certain set of assumptions that have been baked in since the 1950s and 60s. We're on this perfect curve of growth. We just keep stacking up GPUs and forever and ever, and we'll just eventually reach some, Ray Kurzweil singularity. Yeah. But it's quite possible we don't. What does Bruce Sterling say? Everything becomes airlines. Airplanes essentially just hit at a certain point. There's only so much you can do. They're not really going to get any better. Sort of, we can make incremental improvements, but we sort of peaked.
Yeah.
And that could be the same with computation.
So you're saying we've peaked?
I'm saying it's possible that if we look back from like 2050 to today, we could say that was when it started to flatline.
1950, you mean?
2050.
Or 2050?
Look back from 2050.
Oh, look back from 2050. I see. Okay, yeah. Okay.
It's possible that it's like that's sort of when the sort of enabling system structures, maths of computation hit their peak and started to flatline.
Isn't some of this, and I know that we kind of need to, we'll wrap this up, but there's a piece that we're not talking about, which is also like what gets funded by VCs in big tech, right?
Bajillion%. There was a great survey, and I'm going to have to dig it out for the exact statistic, but I'll flash the statistic up on screen now. An anonymous survey of computer scientists who were asked whether the research funding direction was the right way, and I think a third of them said, nope, we're researching the wrong stuff. But that's where the money is. So what else are we going to do?
That's
and
exactly
Sarah
right.
Hooker talks about that in the hardware lottery as well. She's like, and not only that, but you've also got to impress the public and VCs. So you do things like build chess playing machines. No one in the world has ever gone, you know what's going to solve global poverty? Chess playing machines. But you build them because they get a lot of attention. They excite people. They draw attention to the state of the art, blah, 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 blah. And then, of course, the next person has to come along and make a better chess playing machine. And so it's chess playing machines all the way down.
Yeah. That's the future. Chess playing machine.
Of the things I'm paying attention to, this is one of the ones where whenever something comes up, which is largely an academic world at the moment, that's why the CL1 was quite unusual, because they're actually selling as a product. I'm genuinely like, there's a mega trend here, which is that computation is changing.
All right, my
All
friend.
right, we should pick this up again. Right, listen, I've got to. Well, actually, what I'm going to go and do is watch the last 8 minutes of season 1, episode 7 of Andor.
I need to finish. We need to get to Last of Us because we're so behind on that.
I can't recommend Andor enough.
So I know people who like aren't into who aren't into Star Wars who have been talking about Andor,
Yeah.
who like you would never imagine them being into Star Wars, and they're like, this is an amazing show. So
This made G you up a bit just before I joined this call. I was having a little cry.
aw,
Just a little one. Just
it really got you.
very beautiful scene.
Good night.
I will catch you next time.
Sounds good. Toodles. Bye.